Alright, this is part 4 of the video on building a wiggler, and in this part I'm going to conclude it, of course, and show you to start with how to make this little taper here on the pins. And I already made a prototype here, and it's got the ball attached, and it worked just fine. So in the 1/8 inch collet here on the Atlas lathe, I have a piece of 1/8 inch drill rod. Now that is tool steel, but I'm not going to harden it. You could harden it. I don't think there's a need. The included angle of this point is about 20 degrees, so I've got the compound set at 10 degrees, and I have a very sharp pointed tool. And I'll just take it down to a point, and that point is about 1/4 inch long. Now you will need your tool right on center when you're turning something small like this. And this is tough steel. It's tool steel. So we're just putting a point on this like you've seen me do in many other videos, many other projects. And I am going to touch that up a little bit with a file, but trying to stay accurate with it. And just a couple more passes. And that's it. Now here's another option for you. In the collet I have a 1/8 inch hardened dowel pin. I believe it was 2 inches long. And I've got the little Tiny Tim do-more grinder in the tool post, or in the compound rather. And again, compound set at 10 or 12 degrees. And that worked very well, and didn't take very long. The green one here, if you can see the green, is the one that I just did on the grinder. The blue one is the one that I did with a conventional tool bit in the lathe. And I'm going to try a third method here, and in my brand new DeWalt lithium that I bought recently, I have a piece of this hardened dowel pin that I showed you a little while ago from my brother, and I'm going to, with this thing, let's see, in reverse, try grinding it on the belt sander at that 20 degree angle. I'm not convinced that this is a great method. You may have noticed that on the platen here on the table I have a little magic marker line at 10 degrees. I'm not too crazy about this. First of all, I got it too hot, so you can see it's burnt. And this was hardened steel, but that probably took the temper out. Secondly, I don't believe that it ran true, because you can see the grinding line on there, which means that it's not true or not perfect by any means. So that's just an option for your consideration. I'm not going to use that piece. This is the blue one, the one that I turned down with a lathe tool. Just a singular, again, drop of the red Loctite, and I'll put it into this 5/16 ball. Now, why isn't that going in there? I had it in before. Okay, that's it. At this time, I think I'll go ahead and assemble the actual body, because parts 1, 2, 3, 4, 5 are completed. Let me make a comment while I'm at it. For those of you that can't knurl, the possibility of making this out of hex stock occurred to me. I don't have any hex stock, but I'm just comparing this coupler nut, and that's, I believe, 7/16 or ½ inch, but that would be a possibility. I think it would work just fine. Now, you need a spring, and I talked a lot about springs in the previous video about the tap follower, but this particular spring here, came out of the selection that I had that were long pieces, and I just cut a piece to length, and notice that it's and I cleaned everything. But before putting the spring in, I have to load this like my Stevens 16 gauge shotgun. In it goes. In goes the spring, and I have to confess that I did experiment just a little bit with the length of that. And now taking the 5/16 24, that's fine again, set screw. Some of you might call it a grub screw. In it goes, and that bottoms out. I'm not compressing the spring, but I put the thread in there such that it would bottom out, if you remember that. And that's really quite a strong spring. It's very stiff. So I'm telling you, you need a fairly stiff spring. And now that's ready to go on. And this is the one that I turned, the blue one. Let's see, I got so many different ones there. Yeah, that's the blue one. I shined up the ball just a little bit. And that's ready to go, but in review now, in order to change tips on this, and some of you may not want to go any farther than this, you're just going to make the sharpened point, but if you're going to make one of these, and I believe I will yet, or make one of these that is the double ball, it didn't occur to me till just in the last hour, perhaps, that that's not going to work. The hole is so small, I certainly can't run it through there or put the ball through there, as opposed to the way this Sears wiggler is constructed. So, what is the answer, if any? Well, I'm going to have to make this in 2 pieces, and I'm even considering making this in 2 pieces, but I don't think it'll be accurate enough to use. But before I get too sidetracked here, I got one done, and I'm going to make this, and this will be constructed out of just a piece of drill rod that has been bent, and I'll go ahead and turn this piece down on the lathe, drill it, and Loctite it in, and I don't believe I'll put that hole in there. I don't know what that hole is for, to be honest with you. But looking real quick at the dimensions of this, let me get the caliper out. The old Mitutoyo, 214 thousandths and 242, I think 1/4 inch would be, so I'll start with 1/4 inch stock. and I won't turn that down. I don't think that's necessary. I'll double check that 1/4 inch will fit into the last word indicator, so I only have one step to put on there and a hole to drill and tap, so that'll be a simple piece. Here's the last word indicator, and 1/4 inch rod does fit in there, but to be honest with you, just barely. So it'd be nice to have this diameter here just a little bit less than 1/4, and I suppose that's the way it was designed. I'm back on the Atlas lathe constructing just the end part here, and this is what I'm turning down, and that is 216 thousandths, and just a hair less than half, and those dimensions certainly are not very critical. And then I'll round this end off nicely with a file, just to make it look finished. And I'm not sure what that small diameter step is for, because I'll be using the larger diameter, the 1/4 inch diameter. Next, with a cutoff tool, I'm cutting it off to 1 inch. Now, as I mentioned, I wanted this diameter to be just a hair under a 1/4 inch so it would fit into the indicator. So I'm just filing a few thousandths off of it. And finally, I drilled a hole already, and I'm tapping it 5/40, about just a 1/4 inch deep. Doesn't need to be very deep, and you'll see why I want that threaded in a moment. This is a piece of 1/8 inch filler rod for welding. That's why it's copper plated. I'm just using it because it's reasonably soft. I'm not in the mood for threading tool steel. I've already bent it at 30 degrees. That's the approximate angle right there, and I've checked it. I just bent that in the bench vise because it just isn't very critical at all. Now I will cut it off to length in 2 spots, 1, 2, and I'm just going to take that right off of that. And I'm going to thread one end 5/40 so it can be threaded into this piece, and then the ball will be held on the other end, the 5/16 ball that is, with Loctite. Alright, that little piece is done. Threaded 5/40 on one end, and it's got the 30-degree bend. I had to polish it just a little bit to get that plating off of there, but in order to color coordinate things, I'm using the brass ball on the copper-plated shaft here. And again, that was donated by the monkey, the brass monkey in the city park. A little bit of Loctite as usual. A big Loctite fan, as you know. And this piece then can be taken on and off at will in order to assemble it. See, that's the whole idea of this, is that we can assemble it. Now, will this twist off and aggravate us when we use the indicator? I don't know. I suppose so. You know, it doesn't take too much to get some of us angry now, does it? And why isn't that going on? Alright, I cleaned that up with a tap. Now, that's a 5/40. A little known fact now to many people is that 5/40 is 1/8 inch 40. It is a size that is not commonly had in hardware stores anymore because they want to sell things in mass. See how it goes on now. But I'm not going to Loctite that. I want to be able to get it off at will. They go right from 4/40 up to 6/32. But a number 5 is just a beautiful size, so make sure you have 5/40 taps and 5/40 dies on hand, and then you can use readily available 1/8 inch rod. Now number 4 is an oddball if you need to turn it down to a certain size, and so is a number 6. But a 5, well, I'm ranting on that because I love that. I also love a number 12 and a number 14 screw, also not seen too much anymore. Now look what I'm doing. In order to make the edge finder with the 5/16 ball on one end and the 1/4 on the other, and I told you that I cannot assemble it, I'm taking the nose piece off of the prototype, because I'm not going to use this anyway, and I'm dedicating it to an edge finder. So I've already attached the 5/16 ball onto the 1/8 inch drill rod as such, and I will Loctite the 1/4 inch ball on there, and that will stay on there permanently. Whoop. The reason I got this rug on here, the balls don't roll off onto the floor, so that's worked pretty slick. So that'll be my dedicated edge finder. If I may digress here for just a moment, you've seen me use these double-ended tools, carbide tools, in a lot of my videos, most of my videos. I absolutely adore them. They come in both the A size for my smaller lathes and the B size, which I use on the closing lathe. These really are wonderful. Can be used for facing and turning, and you can quick change them and flip them around. So, and I don't work for Shars, but I really do like that tool, and they're fairly reasonably priced. Now you can get the Aloris and the Dorian brand too, but they are going to cost probably 6 times as much, and I don't see anything wrong with the quality on these, so I am really happy with them. I'm going to carry this one step further. Now in the Craftsman set, remember there the needle point looks like this, so it's a actual needle of some kind inserted into the rod with the 5/16 ball with the little sheath on it. So I'm going to attempt to do that. So I just got back from Wally World, and I bought a package of tapestry needles, one of the larger needles that they had. I thought that I would get leather working needles, but these seemed to be visually the right diameter, and they were $1.47. And I'm going to sacrifice one here. I'm just hoping I can drill a hole accurate enough in the end of the drill rod. So let me open this up and see what diameter they are. Okay, I open these up and I am devastated and shocked. Now I have no idea what a tapestry needle is, but they don't sharpen tapestry needles. They're rather blunt. First I thought they were deformed or defective. Oh my goodness. So I'm not going out in the cold weather again, and I already opened the package, so I can't return them. So I sharpened it. But I'm back to that business of sharpening, which I was trying to get away from. So do not buy tapestry needles, but buy some other kind of needle. But I'm going to carry this project through here anyway without another trip to the store. That's the needle I should have used to start with, and I had it here in the drawer, but I wanted to find something that everybody else could find, as if anybody was actually going to do this. But what I've done then is to take the tiniest center drill, which I think is a number 1, and as luck would have it, these basting, these tapestry needles are 1/16 inch in diameter, believe it or not. So I drilled a 1/16 of an inch in diameter. There's a 1/16 inch bit, so I drilled a hole with the center drill and I went in about 3/8 of an inch, and I went back to the soft steel. I knew I would break off a bit like that in hardened steel. And then I cut the needle off with the Dremel, because they're hardened steel. And then I'm going to Loctite the needle in. It's a good fit. And then also Loctite the ball on the other end. Alright, let's review. I have made a complete wiggler set, something like the Craftsman, and there it is. And again, it is modeled after this commercially made one, whatever brand that was or is. And I have the offset indicator holder, I have the needle point and the regular point, and then here is the 1/4 inch ball with an extra nose. So let's go on over to the Bridgeport and see how these work. At the Bridgeport, with the last word indicator held in the offset indicator holder in my new wiggler, and we'll just indicate there, or check the vise to see how far off the jaw is. I'm on the fixed jaw, so I'll just bring this into 0, just showing you how the indicator is held is all I'm doing. So there we are on 0 and running it across. Boy, that thing's almost on. There's some nick. Very good. So that's how you can use the indicator holder. And here's one of the pointers. We're back to checking out the layout lines here on a piece of aluminum. Bring it in so it's true. And using your magnifying glass and a good light, you can get right on your accurately made layout lines. Now let's find an edge, and this is the double ball attachment. And let me tell you now, one of the purposes of the spring-loaded plunger in there is to allow you to change the amount of tension. So you can play around with that if you need to for increasing or decreasing the tension as far as the wiggle here. So, alright, and remember this ball is exactly 250 thousandths, so the radius is 0.125. Alright, remember that the machine has to be turned on for this. And it's wiggling, it's wobbling. Bring it in. Until it runs true. Now if you go a little too far, again it'll spin like that. I went past the edge. So I'll do it again. Might help to put a drop of oil on that, I don't know. Do it again. And there it is. And looking up at my digital readout, which I zeroed out just a second ago, I repeated, so it's on 0 again. Now remember, I'm not on the edge, I am 1/8 of an inch, 0.125 away, so then I would zero out the DRO and crank it in 125, and now I'm truly on the edge, and I could zero it again and make my movements from there. So that's how you find an edge with a wiggler. I meant to show this in the first part of the video and I forgot, but here is a patent from Google Patents from 1914 by Mr. Cooper, and his version of a wiggler. And like I told you, there's just endless possibilities on the way you design this or build it, but there's some similarities here between this and the one that I just completed. So have a look at Google Patents if you want to see some of this stuff. It's kind of interesting. So there it is, ladies and gentlemen, home shop machinists, a wiggler set. Now I would say these two are optional. I'll lay those aside, but these are the essentials, the pointer and the edge finder. And there's a nice winter project for you if you're up to it. Make the extra nose like I did. And I hope you enjoyed this rather long video series, and I'll see you in my next video. And this is tubalcain saying so long for now.